Get comfortable. All right. So for those that don't know, so this panel is going to be called "Loss versus Gain of Function Mechanisms for GBA." So we might as well start. We'll start with Ellen and we'll go. Well, kind of the first question will be is where do you stand? Do you think GBA mutations, variants, is this a loss of function or is this a gain of function? So we'll start with Ellen.
Well, I think one of the problems is how you define loss of function or gain of function, but I'm going to have to say that I don't think it's Yeah, I just was saying it depends how you define gain of function or loss of function, but my vote would be neither. And that's because I just see too many holes in both hypotheses. I don't believe that the amount of lipid that's accumulating in a carrier, especially of a very mild mutation, is enough to drive anything, especially when we know that people, the penetrance is so low in patients that are homozygote that have far more compromised enzymatic activity and hence probably more lipid storage. On the other hand, and we saw in some of the slides today, there are patients with 84GG. There can be accumulation of misfolded protein, but there are some variants that we see in patients with Parkinson's disease that don't lead to protein at all. So it's hard to call that a gain of function. So probably I think that glucocerebrosidase has another function that we don't know about, that it isn't just the enzymatic activity, but it may be the amount of the protein and how it contributes to something else. But I've been thinking about this for probably far longer than a lot of people in the audience, and I don't know. And I hope that some of the younger brains will come up with the answer.
And Ziv, what do you think? Are you for your loss, gain, in between?
Yeah, so, the honest answer is, of course, we don't know, right? But if I had to choose, I would choose loss of function. Although I do agree with Ellen that, I don't know if you got to see, the paper came out in Science Advances yesterday about the GBA and pseudo-GBA, potentially pseudo-GBA even encoding a protein and maybe having a role, a non-lysosomal role. Very interesting paper. I didn't read it very thoroughly. It came out yesterday. So, but that just exemplified what you said, that it's possible that GCase is doing something else that we don't know yet. We don't know about. But when I look at the entire data that is out there, for me, the data that says it's loss of function, it's a lot more convincing. Now, what I think is that we need to we can't think of GBA as a causative gene. So yes, it is a big question why some develop Parkinson's and the most of them do not, although all of them have, let's say, some sort of accumulation of lipids. So why not all of them? But we need to think about causality as a pie. You have to have many pieces to this pie coming together in order for you to have Parkinson's. So that's just one piece of the pie, right? You have reduction of GCase activity, and that makes people more susceptible, but they have to be exposed to other things in order for them to eventually develop Parkinson's. That's what I think. The strongest evidence for loss of function, and there's a lot of it, but you mentioned 84GG, so of course there are all these null mutations that they do not create a protein, and if there's no protein, well, at least it cannot be a gain of function unless it's something at the, I don't know, RNA level, but it doesn't make any sense with the biology that we currently know. So I think that based on what we know now, I would vote for loss of function, but we cannot rule out that at least in certain cases, when we have ER retention with specific mutations, that can maybe exacerbate the phenotype, make it a bit worse, or things like that. But I don't think that's the main problem here. The main problem, in my opinion, is lysosomal loss of function.
So Ziv's almost hedging his bet. He took a guess and kind of went in the middle almost. But Joe, what do you think on this?
Yeah. So I guess you want to keep an open mind about this, but I honestly, when we started studying this a long time ago, it was just mainly considering loss of function mechanisms. And that was part of the reason is because of what Ziv said regarding the mutations, where you have null mutations, that you can get the same end effect as with some of the point mutations that cause ER stress and other things. If you knock down the gene, if you knock down GBA1, eliminate the protein and activity, and lipids go up, then that's sufficient to cause, for example, synuclein accumulation, which is the main thing we look at. And the same thing is true with when you have wild type GBA and you add CBE to cells, you can achieve the same effect as you would with the mutant. So that's the main reason. Now, regarding the lipid data, I think that's hard to consider because, well, first of all, you know, we see lipids accumulating in relatively homogeneous population of neuronal cultures, they're midbrain cultures, even in the context of wild type GBA. If you have synuclein accumulating, it's enough to inhibit GC activity through direct mechanisms, or we have shown through trafficking, and that's enough to rise the glycolipid levels. Some of the studies in brain are complicated by mixtures of cells and other things, looking at subcellular organelles, for example. It's hard to do and get an accurate measure. Glucer's in many different cell types. It's in glial cells and neurons, and so it's hard to get an accurate measure in the brain. I do think that, you know, one of the slides I showed was that there is this redistribution that of glucer that may happen where you're forming, maybe you don't even get a accumulation of glucer, you just get a redistribution of it, and it forms these lipid rafts that can trigger synuclein aggregates. So, you know, according to what we have seen in our in vitro and mouse models, it kind of lines up more with loss of function, although you can't exclude that possibility that ER stress, we know ER stress is going on with the mutants. It's occupying chaperones and maybe possibly overwhelming the system. But I just can't, logically, I can't think, how would ER stress lead to Parkinsonism specifically and not give you some other neurodegenerative disease? I can't, if there's other comments about that, I'd love to hear them.
So we'll open up to the audience in a sec, but Stacy, last but not least, for,
Yeah.
against, loss or gain, or in between?
I think if you look proximally at GCase function, the majority of the data supports loss of function, right? If we look, and Oliver will talk about this in his talk later, if you look across the variants, we see loss of GCase protein, especially in the lysosome. So I think as you think primary consequences in GCase, it seems deficiency is associated with PD. But it's a different question as you think about what are the secondary consequences. And you know, our data at least suggests that it's not a one-to-one correlation in terms of the extent of lipid accumulation you see with respect to secondary pathway dysfunction. In the E326K variant that we've been characterizing, you see these broad defects that are much more severe than you look at some of the other, like alpha-4P or knockout settings. So it could be through compensation or other things that you're seeing more severe phenotypes, which essentially almost look like a gain of function, but it's due to a primary loss of function, we think.
Okay. Ziv, you said you wanted to
Yeah,
say
so I just want to make a quick two comments. One, about the ER stress, I agree with Joe. I can't think of something like that either. And more than that, almost everyone in this room carries some rare mutation in some gene that creates a protein that is misfolded, and we all have rare mutations and potentially get stuck in the ER, for sure, some of us. So what is unique about GBA that protein gets stuck in the ER and that leads to Parkinson's? Why other proteins that get stuck? And maybe what we see the ER stress is not because of the GBA at all, but because of synuclein somehow. I don't know. But that's comment one. Comment number two, I mean, there are many people in this audience that could have or maybe should have even sit in this panel as well. So I just want to invite other people to also go up to the microphone or ask them to speak and say what they think, because I'm sure Greg here.
Well, before, I'm going to get to Greg's question in a sec, but quick question out of, everyone here, show of hands, who would be for a gain of function? Just out of curiosity. If you say yes, I'm not saying yes, but if you think it's a gain of function, hands up in the air. Okay, one, maybe two. Is a loss of function? Okay, and then somewhere in between. Okay, so maybe more loss, partly gain. Okay, so maybe we'll open it up to some comments. So Greg, do you want to start?
Yeah, to me, doesn't really matter. And could it be both?
Could it be both?
There are data that should be repeated about the role of a mutant glucocerebrosidase causing abnormal uptake of alpha-synuclein into cells and causing aggregation. That's a gain of function, okay, from a misfolded protein. We have all these funny terms. We have severe mutations and mild mutations. They're mutations. We should not peg them like that because we're giving ourselves a brainwash as to what we should be seeing. N370S is called a mild mutation. That's why it kills some people. And it does. L44P is a severe mutation, and I have normal people with this in their 50s. Completely normal. Yeah, they're getting enzyme for their visceral disease, but they have no brain involvement. So, I mean, there's a lot of language here, but I do think that one of the difficulties is E326K. It is, at least in vitro, when you mutagenize glucocerebrosidase, that enzyme has a catalytic rate constant that is 50% of wild type. So a person with wild type and E326K has 75% of normal enzyme activity. That's within standard of error of measuring the enzyme. The question is there something else going on with that enzyme? And so I would say keep an open mind about these things. In a sense, if it matters, why does it matter? And can you fix a gain of function? Yeah, likely. Can you fix a loss of function? Not so sure.
Very good. Any thoughts from the panel or any questions? Or maybe thoughts from the panel and then others can then ask some questions afterwards or comments.
So I mean, I will have a talk about severe versus mild and all this mutation, and I will try to convince you that it is important for certain things, but it's not for now.
I saw Roy, you have your hand up?
Greg, coming to our clinic, if you see sufficient patients with severe versus mild mutations, you'll see that there's a difference. It's beyond statistics. It's a clinician's eye level of differences in the phenotype. I wanted to just because we talked about loss of function versus gain of function, there's an abstract that is going to be a platform at the MDS, and we didn't submit it here. With Sanofi, we queried the registry of Gaucher patients to plot age-specific risk for Parkinson's. And according to the registry, that if anything is skewed towards more, by age 80, 12% were diagnosed with Parkinson's. And if we take a very liberal diagnosis, it's maybe like, and that's like falls and cognitive impairment would be Parkinsonism. We go up to 20. So it's not the diagnosis. It's the majority of Parkinson's of Gaucher patients, even by age 80, do not develop PD as we know it or as we call it. So it's not just that we just didn't follow them long enough. I think it's solid that a lot of them don't develop PD.
And are you saying that this argues for maybe not loss of function?
Like if you argue for a nonlinear loss of function, at least you may say that there's a level that it's a U shape or whatever, but it's not. If it's
once you reach a certain level, that's it. You're at risk. And
so, according to the geneticists that you're among them, the odds ratio of risk for Parkinson's in a single mutation carrier of 84GG is higher than a double carrier of N370S. Now we can say, okay, maybe the data the geneticists are working there is not great. Maybe the data from the Gaucher clinics is not great, but it's repeatedly shown the same fact that you're better off with 2 N370S mutations than in one 84GG for odds ratios for PD.
Just to confirm what you said, we've finally been able to get about 5 autopsy samples, brain samples from patients with type 1 Gaucher disease. Those are the hardest to find because they never used to go to autopsy, and we hadn't seen any indication of Lewy body disorder, and some of them were quite old, or at least over 80. So that sort of, to me, tells me that you can't say that everybody's on this trajectory in any case. The other thing is my general observation, and it's against the literature, but I seem to think that heterozygotes and homozygotes have about equal risk for Parkinsonism, and I think the phenotype's fairly similar.
Over there.
Thank you. I have a question that is not related to gain of function versus loss of function. Does anybody in this audience have any idea why the dopamine neurons are so susceptible to the GBA1 mutation?
Well, I don't know. I guess in terms of GBA1, if GBA1 loss leads to accumulation of synuclein, then we know that there are some links between synuclein and catechol binding, for example, to dopamine is one of those catecholamines that it binds to. But that's a good question. I mean, there's many special things about dopamine cells at the electrophysiological level. They're energetically active. They expend a lot of energy and could therefore create oxidant stress. And that the oxidant stress thing is really, at least for me, probably the best explanation for why they're sensitive. We know that they're under oxidant stress because the substantia nigra is black because it's a product of oxidized dopamine. So we know it's there. It's normal, actually. And so that may have something to do. But how is that connected to GBA1? Well, I guess there is a connection between dopamine oxidation and GBA1 activity that has been published. And yeah, and possibly iron as well, which is concentrated in the neuromelanin. That's a good point. The dopamine, how dopamine is fluxed. Yeah, and that creates peroxide, and I think
This is the question that's always driven me nuts about this field. Okay? Is it true that dopamine neurons are more susceptible, or just that we notice because they're black, and we notice the loss of dopamine neurons, and because they produce motor symptoms, and because we can treat those motor symptoms with dopamine replacement? Is it really true? Is that a fact? Because people expend so much energy wondering about that, and I don't think they're the first cells to go. Are they? I mean, what about in RBD? Are those dopaminergic neurons?
Well, they're not
brainstem?
affected yet to the level where you see symptoms, but there is some, when you do DAT scans, you do see in some RBD patients. Yeah, noradrenergic, yeah. But
So they go first.
yeah, potentially. But it's true that obviously not only dopaminergic neurons are, but one study that I really like from Ivan McCosko at your neighbor in Boston, not MIT, Broad. He showed, he did single cell analysis comparing PD patients and controls, analyzed the substantia nigra from postmortem patients, and what he was looking for, it was published in Nature Neuroscience, I think, last year. What he was looking for are there actually subtypes of dopaminergic neurons that are more susceptible for degeneration. And what he was looking for are cells that are more prevalent in healthy in people without Parkinson's versus Parkinson's. And he did find a couple of those. He identified, if I remember correctly, 10 different types of dopaminergic neurons based on their expression profile. And a couple of them were, one of them was especially the most susceptible for degeneration, meaning that in Parkinson's you won't see this type of neuron almost at all, and in healthy individuals you will. So I thought it was really interesting, and I think you're right in the sense that yes, it does not affect only the dopaminergic neurons, but in that environment, even if the substantia nigra, there are some dopaminergic neurons that are more susceptible than others. And there is a reason for that. We just don't know what it is. That's what we, you know.
Let me just
Ricardo.
say one more thing since I have this. Just all of Ziv's comments should be filtered through his
Oh, come on.
certainty about the NBA. All right, I use this all the time. Maybe a lot of you aren't sports fans. I'm a sports nut. You can gauge somebody really by engaging them in a sports conversation. When they make one mistake, I often put them in a different pile. So
Yeah.
Anyway,
I'm not going to talk about your mistake.
I
Peter,
would
so
I would say
my mistake was minor.
I would say the idea. This is the first time I've heard this, that Gaucher patients have a lower relative risk than patients bearing the null. So that doesn't make sense given what we talk about. But maybe it has to do with rescue. So you could rescue N370S, and a lot of things happened, as you referred to a lot, Stacey. I was really happy about using that word, because there are a lot of compensations that happen when GCase activity is low. And that's why the penetrance is so low, in my opinion. And that's why it's hard to rescue. It's hard to compensate for mutant, that you just have half the protein to work with. And so that's my BS explanation.
It could be, but I can tell you that from my experience, but I didn't work with the Gaucher side of things from Parkinson's. So when I screened Parkinson's cohort in Israel, when I was in Israel, it's true that when we look at that Parkinson's cohort, we did identify out of 1,000 people, like 12 of them had homozygous or compound heterozygous mutations, and 84GG indeed have higher odds ratio. Only one of those 12, by the way, was diagnosed with Gaucher disease. All the rest didn't know. Either they had very mild symptoms or almost no symptoms at all. But my point is that it is possible that those that did have symptoms had Gaucher disease. They never made it to the Parkinson's, to the age of recruitment, or if they did, they never made it to the clinic or something like that. So the fact that they had more clinically significant Gaucher disease may have prevented them from participating in the Parkinson's study. So that could be another reason, simply a bias like that. So, but I don't know the answer, if it's true or not. That's just what I mean, that's from somebody who studied Parkinson's.
Yeah, but somebody from the Gaucher side of things, I think that we see patients with Gaucher disease far more frequently in far more centers than the average person who doesn't go for follow-up. And I also think that, I don't know why you would think that you'd be missing it. Right now, the life expectancy of a patient with type 1 Gaucher disease, if they're treated well, is getting pretty close to the general population. So I don't think you're going to get a lot of dropouts, especially with type 1 Gaucher disease. Now, whether type 2s, if they had lived long enough, they would have developed it, that's a whole other story.
Heidi?
Thanks. I just want to put a plug in for the specificity of the dopaminergic neurons from the context of Malou's talk, where there are a number of us who are looking into the role that PD starts in the periphery, right, in terms of the immune system during infection and other types of hits. And so then the question, we still ask ourselves the same question: why would then, even if you have a T-cell mediated or immune mediated death, why would that be selective for dopaminergic neurons? And one thing we're looking into is coming from David Sulzer, that these neurons tend to express MHC1 in the presence of activated microglia as a response to local inflammation. And I think, obviously, in neuronal development, MHC1 is involved in axon guidance, in laying down the tracks. So it could reflect the high arborization of those neurons to rewire during inflammation. So you start to express MHC1 as a residual developmental phenotype that they could then also be presenting antigens. So I think, and it's also clear that it's not only dopaminergic neurons that do get hit in patients. That's important to keep in mind as well. But I just wanted to make the point about the immune sensitivity of those neurons.
Maluza?
So to add to what Heidi just said, one of the other things that makes the dopaminergic neurons more vulnerable is the fact that they require TNF to develop a dopaminergic fate. Martin Levesque had studied this, and so engrailed is needed for the dopaminergic fate, and you need TNFR2 signaling for that. And what happens is that they continue to express TNFR1 receptors, but the R2 receptor, which is the more protective receptor, goes away. And so they're targets for any little bit of soluble TNF in the area. And we and others have done experiments where if you put dopaminergic neurons in the dish, Peter, their TNF sensitivity curve shifts all the way to the left when they're oxidatively stressed. If they're not oxidatively stressed, TNF doesn't do that much to them. So it's the perfect storm of oxidative stress, protein aggregation, and inflammation. Cortical neurons, hippocampal neurons, are not as susceptible to inflammation because they have a lot of TNFR2. And in fact, when you have a stroke, you need TNFR2 to proliferate the hippocampal neuroblast and repair the area. So it's an outcome of evolution and receptors that didn't go away and the circumstance of the microenvironment of where they live. And the noradrenergic neurons go first. Norepinephrine serves an anti-inflammatory role, and we think that that is what makes the progression to Niagara and other areas more likely, because with norepinephrine gone and the locus coeruleus gone, you lift the roof off the house in terms of inflammation.
Okay, last question, or last comment.
So I mean, I think there are two questions. One is the loss or gain of function question, which I agree is an important question. I favor loss. But the other question related to the low penetrance, I mean, to me is not very surprising at all. I mean, this is the problem of complex disease. It's not just a GBA Parkinson's disease problem. We have the same problem in the Alzheimer's disease field with ApoE. It's actually a bigger problem there if you look at the conversion rate amongst ApoE. So, I mean, I'm curious why it kind of trips us up in the Parkinson's disease field to try to explain this problem. I think it's a much bigger problem. You know, you could argue compared to the 100 other Parkinson's disease risk alleles, you know, we're kind of fortunate from the standpoint of thinking about GBA that we're dealing with at least a 5-fold risk. I wonder if it has something to do with the connection between GBA-PD and Gaucher's, that we find it an unusually difficult puzzle to try to connect what's happening in Parkinson's disease to all that we know about GBA in Gaucher's. But anyway, I just wanted to make that observation.
I think you would have assumed in a case like this that homozygotes would be at a higher risk than heterozygotes, and since we don't really see that, it's surprising for.
But it's not a linear process. You're just saying that 2 is worse than 1. That's not true in a lot of things. So if it's not a linear, if it's not
If
linear,
it's loss of function, then
well, if
it
it's
is
pure, but if there's compensation mechanisms or complicated ways to get around the problem.
Yeah,
Josh, educate us, because I may not, I actually don't know. Are there clinical trials targeting ApoE4 for Alzheimer's? Because we are talking about clinical trials targeting GBA for PD. And if the penetrance is That's the question here. Like, how do you handle that? And I don't know if clinical trials for ApoE4. ApoE4 carriers are often segregated. Yeah, they're segregated. There's no. Are there clinical trials? They're coming. They're coming. Okay.
Yeah,
When
but-
they're coming, we'll have those discussions here. That's.
Yeah, but one response to that would be maybe the trials for GBA-PD are premature. I mean, because we need to understand how GBA-PD actually is caused. But I think, I mean, I agree. It's surprising, Ellen, that the homozygotes don't clearly have higher risk. But at the end of the day, I think Ziv kind of, to me, gave the answer, which is that we can't think of it as a kind of linear single hit. You lose GBA and you get PD, but we have to be factoring in aging, a variety of environmental risk factors, both known and unknown, the rest of the genome, which is almost certainly modifying things. So, I mean, it's almost amazing that anyone would find a difference between Gaucher's individuals having increased risk compared to the heterozygous carriers. I mean, I think this is complex.
Well, but if you're going to blame the lipid as a loss of function,
All right. Well, this has been a great.
well, I think the other thing that we should be thinking about is not only risk factors, but protective factors. Why the two siblings with the same mutations, one gets it, one doesn't?
All right. Well, we're out of time, so let me thank the panelists. Great discussion. And then we'll be meeting back here at 3:30, so for a data blitz. And then there's going to be coffee, so you can continue to chat outside. Thanks.